Hi statistics students, this is Dr. Bielingmeyer. We're going to do a review of the homework in Chapter 2, starting with question 1. 30 fathers were asked about the highest level of education they had completed. 10 completed only elementary school, 10 completed elementary and high school, 7 completed all levels through college, and 3 completed all levels through graduate school. What was the cumulative percentage of fathers who completed only elementary school? Round to the nearest whole number. I made this in a little chart form here. So we would take 10 people who completed only elementary school divided by the total number of people, which was 30, and we get 33% for the cumulative percent. You can review that concept on the Chapter 2 presentation that comes at about slide 6. Okay. Drop that. Question 2. In your study of 40 people, 8 had no cold symptoms, 12 had mild cold symptoms, 9 had moderate cold symptoms, and 10 had severe cold symptoms. 1 patient was lost to follow-up and no data could be collected. What percentage of patients reported cold symptoms? So any of those categories that reported cold symptoms, despite whether they were mild, moderate, or severe. So that means we're going to add 12 and 9 and 10, and we're going to get 31 divided by 40 to give us 77.5, or rounding to 78%. Question number 3, given the information in review question 2, what was the percentage of patients who reported no cold symptoms? That was 8 divided by 40 gives us 20%. Use the frequency distribution in table 2.5 or 2-5 to construct a bar chart for influenza cases in your hospital during 8 months in 2017-2018. Would your chart look different if it were a histogram? So you can construct a chart and then discuss at least one rationale for selecting either a bar chart or a histogram to present data. So in the histogram, the columns would be touching to display ordinal or continuous data. The lack of spaces reinforces that the responses are on a continuum. Questions 5 through 7, your community begins a large-scale influenza vaccine effort, and the following year, the number of cases drops. See Table 2-6. Now I want to draw your attention to Table 2-5, influenza cases for, that should say 2017 only. And then Table 2-6, this should say influenza cases for 2018, which is going to impact how you do question 5. So construct a line graph showing data from 2017 from Table 2-5 and the data from 2018 from Table 2-6 and compare the two. So here you should have made a line graph overlying the 2017 data with 2018 data, noting that beginning October there was a substantial decrease in cases with the large-scale influenza vaccine effort. Question 6. Why didn't the numbers change significantly for August and September? Well, the flu vaccine is usually administered in the fall, so the cases that occur in August and September are really before vaccinations are given. Question 7, do you consider the vaccine effort to be successful and why? Yes, because there's a substantial decrease in cases beginning in October after the vaccine was administered. Question 8. Construct a bar chart for mother's marital status. So if we look at mother's marital status in Table 2-7, we have single, married, divorced, and other. And he did do a bar chart. So we will go there. And there you see I have a bar chart, which you could draw on paper. You don't need to do it in Excel. I just did it here because it's just a little neater and prettier that way. Okay, question 9. What percentage of adolescents are employed and what percentage of adolescents are in school? Are these variables quantitative or qualitative? And we'll round to the nearest tenth. So the first part of that, adolescents that are employed, we have 25 adolescents that are employed out of a total of 92 adolescents surveyed, giving us 27.2% of adolescents employed. Then the next part of the question asks about adolescents in school. So we have 45 adolescents that are in school, divided by the total of 92 adolescents surveyed, giving us 49.4% of adolescents that are in school. These are qualitative variables. You can review Chapter 1, about slide 8 of that presentation to help with that information. Question 10, identify the level of measurement of each variable. So we have some nominal variables, that is pregnancy, student status, mother's marital status, and employment status. So they either are or are not in one category or another. It's simply categorical, nominal. And then we have some ordinal data, and that was age and number in household. And the reason that age is not interval or ratio level or scale level is because it was grouped. So you're grouped into less than or equal to 14 or 15 to 17 or 18 to 19. So the way they measured age happens to be ordinal. Question 11, could any of these variables have been measured as continuous quantitative variables? Yep, we could have measured age and number of years in school and years employed, and then we would have had continuous quantitative variables. Now, question 12, construct a histogram for the ages of the adolescents and describe the histogram and what it tells you about this sample population. Why would a histogram be appropriate for this choice presenting data? Because these are, go here, histogram, there we go. So really it helps us to look at the age breakdown. The majority of subjects were over the age of 15, with about half under 17 and about half over 17. And that's pretty easy to see when you do that histogram. Question 13, is the pregnancy status of this group of adolescents typical? Not really, because all the adolescents were waiting for pregnancy or family planning related services. Question 14. You've been recruited by the head of the Federal Emergency Management Agency, or FEMA, to act as the head triage nurse for a large city's hurricane response team. One of your main duties is to decide which nurses will cover which facilities in the overall relief effort. Because most nursing duties will have to change during this shift in personnel, you decide to divide the group based on years of experience. Your nurse's aide carries out a brief survey of all personnel available, which is 100 nurses, and gives you a list of the number of years of experience for each, and you can see table 2-8 for that. Find the quartiles of this distribution and assign a role to each nurse. For example, the nurses with the least amount of experience should be assigned to the rescue team, and the ones with the most experience should be assigned to the intensive care unit. So nurses with 3 or fewer years of experience should go to the rescue team. Nurses with 4 to 6 years of experience should go to the stadium. Nurses with 7 to 10 years of experience to the hospital team, and nurses with 11 to 40 years of experience to the ICU team. Question 15 to 18. A diabetes educator is working with a group of 15 patients who have been newly diagnosed with type 2 diabetes. She administers a brief pretest, reviews carbohydrate counting with them, and then asks them to complete a post-test assessing their knowledge of the total grams of carbohydrate found in one serving of 4 sample items brought to the class. The test results are shown in Table 2-9. Complete the cumulative frequency column of the table. So on page 39, the cumulative frequency column is completed for you. You can review that. So that is 1, 1, 2, 6, and 5. What percentage of patients answered all 4 questions correctly? So you have 5 patients that answered all 4 questions correctly, divided by the total of 15 patients, so you have 33%. You add another column to the table and calculate the cumulative percentage. Don't look at that just yet. So that the cumulative percentage for the first row is going to be 1 divided by 15 people equals 6.7%. And then the next one is 2 divided by 15 people, and you get 13.3%. The next row is 4 divided by 15 equals 26.7%. The next one is 10 divided by 15, or 66.7%. And the last one is 15 divided by 15, or 100%. Question 18. The diabetes educator would like you to present her result in a grouped frequency table showing the frequency and percentage of those who passed the post-test with greater than 70% and those who didn't for the report she has to make to the funding agency. And we want to show our product, and that is here. So we have the subject scoring less than 70%, which is 4 people, and the percentage of the total is 26.7. And subjects who, oh, I have a typo there, subjects who passed the exam, so then we have 11 of those folks. I have 2 typos there, which is 73.3%. Okay, moving on to question 19 through 20. A researcher examining patients diagnosed with sarcoidosis would like to look at a trend in their inflammatory markers. The researcher would like to use a graph that can illustrate the erythrocyte sedimentation rate, or SED rate, and the C-reactive protein level for each individual in the study, and thus show the relationship between 2 markers. What graph representation of the data would you suggest? And the suggestion there would be a scatter plot. And you can go back, please, to page 29 to review scatter plot. They're a little different from the previously discussed graphs in that each point represents how one subject relates to 2 variables. So that's very important. Question 20. After creating this graph, the researcher notices one of the subjects is significantly below the trend line and that other subjects seem to follow. What might be a logical explanation for this outlier? There could be a person was incorrectly diagnosed, or the data was incorrectly entered, or the person had significantly less inflammation than his or her peers. This individual is responding better to treatment, are a number of examples that could be impacting that outlier data. Question 21. An emergency room nurse working in a hospital in the wine region of the Finger Lakes in New York noticed a seasonal trend for ocular injuries from bottle corks. She would like to illustrate this graphically and develops a histogram. Why might she prefer a histogram to a bar chart? So a histogram, remember, better illustrates the continuum of time from one month to the next with an order involved. Question 22. When the nurse looks at her data and the histogram, it is apparent that more ocular injuries from bottle corks occur in October, which is wine fermentation season, and January. She also notices that more of the injuries involve the right eye, provide a reasonable explanation for both the January peak and the prevalence of the right eye injuries. Well, it could be that January is when New Year's occurs, and more people could be right-handed than left. Question 23, the nurse would like to determine if more ocular injuries are associated with wine bottles from Shakespeare or Sharespeak winery or with wine bottles from Francisco's winery. What would be the independent variable? So the winery is the independent variable. And the next question, 24, is what is the dependent variable in the review question 23, and that would be eye injuries. Eye injuries is the outcome. So you can review that back from chapter 1, about slide 7 of the presentation for that chapter. 25, you are tracking melanoma in your county. Calculate the race and gender specific mortality rates from the data provided in table 2-10. So you can, this is in your textbook, provided already, but row 1 for men, the mortality rate is 0.008%. For women, it is 0.004%. For whites, it is 0.0075%, and African American, 0%. Offer a potential explanation for why race-specific rates may be different for whites and African Americans. Well, it could be that different colored skin, because melanin protects from UV light. Different cultures have different prevention behaviors, different exposure times, difficulties diagnosing on darker skin, or differences in access to health care, etc. Could be in many reasons. So 27 says complete the following table. So here you have number of subjects in the sample in that middle column. So you're missing a 4, so it should read 1, 2, 4, and then 1, and filling in 3, 4, and 6. and the cumulative frequency. So you're just adding row 1 comes across, there's a 1 there for the first cumulative frequency, and then the number of subjects in the sample that go into the 6 to 10 age range, you add 2 plus the 1 in the first cumulative frequency area and you get 3, and you continue on down. So you add the 3 to the 4 to make 7, and then you have the 7 plus the 1 is 8, and 11 plus 3, I messed that up. 8 plus 3 is 11, and 11 plus 4 is 15, and then you have 15 plus 6, so your last number is 21. So the cumulative frequency column should be 1, 3, 7, 8, 11, 15, and 21. Questions 28 and 29. The Centers for Disease Control and Prevention provided Table 2-11 and Figure 2-12 showing mortality rate data from Delaware and California in 2014. 28 is your colleague has a pending job offer and decides he will accept the offer in Delaware because too many people die in California every year. Do you agree with his decision? Why or why not? Well, though the absolute number of deaths is higher in California, the population is also substantially higher in California. So when we look at the mortality rate per 100,000, we find that the death rate is substantially higher in Delaware. Then 29, which is more effective for presenting data about mortality rates, the table or the bar chart, and why? So putting rates rather than the absolute numbers in the bar chart helps to illustrate more clearly the different mortality rates between the states that are so vastly different in size. Question 30, Table 2-12 presents data from the CDC that tracks Ebola cases in Sierra Leone in June 2014. Complete the cumulative frequency columns. So Table 2-12. I believe I have for you on Excel. It's question 30, yes. Okay, so this is what this table should look like filled in. The cumulative frequency cases and the cumulative deaths. So here I have highlighted yellow what you should be filling in. I'm going to move on to question 31. Which age group has the highest incidence of chlamydia? What explanations might the researchers offer about this data? And this is from Figure 2-13. So the highest incidence rates are those who are age less than or equal to 25 years old. And explanations may be having greater than one sexual partner, practicing riskier sex behaviors, or engaging in more frequent sexual activity for people in this age bracket. Question 32, which group has the lowest incidence of chlamydia, and what explanations might researchers offer about that data? Well, lower incidence is found in those aged 36 to 45. Could be that there's fewer sexual partners, safer sex practices, less frequent sexual activity during this age bracket. Also might be that the group over age 45 includes much larger age range, so the actual number of people in that age group impacts the incidence and makes it higher despite what might be safer sex practices. Question 33. If you were going to design a chlamydia prevention campaign, what age would you suggest targeting and why? Maybe less than or equal to 25 because of the higher incidence and more long-term risks from early infection. May also include all under age 35 because that captures the two highest incidence age groups. Okay, that concludes the review of Chapter 2 homework questions. If you are confused about any of that content, please review the chapter lectures and review the content area in the textbook, because sometimes when you go back and look at those things become more clairvoyant. You are welcome to use the course tutors, or obviously contact your instructor for assistance as well. I hope that that was helpful to get the answers, and if you need anything from us, please reach out to us. We don't know you have questions unless you ask. Take care.